Okay folks, welcome to another fun and exciting episode of Math with Marty. And today what we're going to be talking about is impulse. Now impulse is the change in momentum. Okay, so we talked about momentum in the last video. Momentum is P equals mv. Okay, so impulse is actually the change in momentum. So I better explain what these are. So that triangle means change in. Okay, what that means is a difference of momentum. And then P, of course, is the momentum vector. So this is momentum. Okay. Now this is going to be equal to, P2, the final momentum, minus the initial momentum. So here's what we're going to say. Let's suppose that you have a spaceship. Okay? You've got a spaceship. I don't even know if that looks like a spaceship, but let's say it does. Let's say that is a spaceship. Let me draw it a little better. Okay, let's say that is a spaceship, and it's traveling with some velocity v, and it has some mass m. What I'll say then is that the initial momentum p1 equals m times v1. All right. So the initial momentum is p1, and it's traveling at a constant velocity. So this is a constant velocity. What Newton's first law told us was that any object maintains its motion unless acted on by an external force. So let's suppose that the ship turns on its thrusters and it applies a force. So now ship applies thrust. So that means a force for some time t. Then what that means is that the impulse I is actually going to be equal to F, the force vector, times t. Okay, and I'm going to show you, and I'm going to demonstrate to you that's true based on the fact that the impulse is the change in momentum. Okay, watch this. Let's go on to the next page. So if I equals ft, where t is time, f is force, and what we learned in the second law video was that F equals ma. Since that's true, then I is just mat. Okay, I is just mat. But the acceleration is actually how velocity changes over time, which is something that we've also covered. Okay, now what that means is after some time t, the velocity goes from v1 to v2, which means that it's changed. So if that's a, and I plug that back in, the impulse is going to be m v2 minus v1 all over t times time. Now what do the time variables do to each other? Well, one's on the bottom, one's on the top, they cancel. And if I were to expand that m inside the bracket, what I would get is mv2 minus mv1, which means that the impulse is p2 minus p1. It is the change in momentum. Okay, so I've derived it, and now I've demonstrated that there are actually two formulas for the impulse. So therefore, you can determine impulse, or the change in momentum caused by some force, through two equations. One, Ft equals I, and then the other is I equals P2 minus P1 after some force has been applied. But really, folks, these are absolutely identical formulas as we demonstrated just now. We went from I equals Ft all the way to I equals P2 minus P1. Okay, now that is the change in momentum, and one thing that I do want to say is that the impulse itself is a vector quantity. Okay, what else? So all I've said here is that the momentum can change. So momentum can change. Now, how can momentum change? Okay, there are three ways. One, its mass can increase. Okay. Two, speed can change, decrease or increase. And three, direction of the object can change. So really the force is only going to be affecting two or three. Okay, a force can cause an object to speed up, which means that its momentum has changed, or a force can change the direction of an object. Okay, and we'll see later an example of a force that does that, like let's say the centripetal force, okay, or gravity as a planet orbits a star, right? So those are cases where momentum can change. So just a summary, impulse is the change in momentum. It can also be determined by force applied times time in which it is applied, and momentum can change by speeding up or a change of direction. I hope this video was insightful. If it was, if you enjoyed it, leave a like, subscribe, comment, and I'll see you in the next one. I love you guys. Peace out. Bye-bye.